Greetings to all the viewers. Now we entered into the new concept called organic named reactions. This is the content we retrieved from textbook of organic named reactions, which are written by Dr. Kavita Kottireddy Kota. Right. So we are going to conduct the series of sessions based on organic named reaction in the alphabetical manner. The entire content is available at the channel called World of Competitive Chemistry. Let me start with acetoacetic ester, right? Acetoacetic ester condensation, which is alternatively known as Claisen condensation. This is the part of organic named reactions. So here, the name of the compound, IUPAC name meant for International Union for Pure and Applied Chemistry naming will be there. Ethyl 3-oxobutanoate synthesis, right? Ethyl 3-oxobutanoate synthesis we are going to perform. This is the synthetic procedure for new carbon-carbon generation. Carbon-carbon bond formation taking place in this procedure. When two esters or one ester with another carbonyl compound are supposed to be treated in the presence of strong base like sodium ethoxide. Sodium ethoxide is able to condense the two kind of compounds, either esters or ester and carbonyl compound together. And what are workup taking place in order to achieve the product? A beta keto ester or beta diketone will be the final product by this named reaction called Claisen condensation. Claisen is the successive scientist who established the reaction in the year 1887. Claisen condensation is named after German chemist Ludwig Claisen. Is a fundamental carbon-carbon bond formation reaction in the organic chemistry. It's widely used in the synthesis of complex molecules within the laboratory that also extended for the industrial applications as well. If you want to see the schematic representation of Claisen condensation, the ester compound was taken initially, treated with another ester in general. So, in the presence of strong base like sodium ethoxide, under water workup conditions to be operated, beta keto ester will be the final product. There will be the condensation taking place between these two. One of the OR group is discarded, and another compound where this active methylene carbon atom is participating in condensation with this one, so that chain elongation in the new form of carbon-carbon bond is possible. Alcohol is given as a final product. So you can simply observe the reaction. This is the kind of ester. In either ketone will be taken, alternative component, alternative reagent for the condensation will be a ketonic one. There is a formation of diketone is also the possibility. So this is the way Claisen condensation giving rise to either beta keto ester or 1,3-diketone as the final products, right? So simply I'm taking the reaction between the ethyl acetate of 2 moles, sodium ethoxide taken as a strong base conditions for the condensation process. There is a formation of condensed product beta keto ester as the final product, and ethanol will be the byproduct originated. And the same reaction is manifested in the skeleton, chemical skeleton form, chemical structural form. Ethyl acetate of 2 moles will be treated with sodium ethoxide and water workup taking place. And here is the product ethyl acetoacetate. It is the industrial synthetic pathway for ethyl acetoacetate manufacturing. Ethanol will be the another byproduct you can clearly observe over there. Same reaction is also manifested with ethyl acetate and ethyl acetate together. Sodium ethoxide treated, ethyl acetate formation giving rise to ethanol as the final product. In order to observe the reaction mechanism, first of all, ester compound to be treated with base so that here carbene will be originated. That carbene origination is the step number 1, which can be involved in the resonance so that enolization taking place within the molecule. Later on, that whatever carbene generated can be treated with any other ester molecule so that condensation taking place and chain elongation is possible. Alkoxide ion is whichever generated will be further go for the final product formation. This final product formation that is represented in the schematic form. Ethyl is, for example, I'm taking a ester compound treated with strong base. Alpha carbon with respect to functional group adjacent to carbon is designated as alpha carbon atom. Under basic conditions, the sodium ethoxide is more suitable for the protonation of this one. Being this carbon experiencing the pulling of electron towards this ester functionality, it is the electron withdrawing functionality, so that protons are more viable for the separation, being they are acidic in nature. That's the reason why strong base sodium ethoxide will pull up the proton from this carbon atom, and hence you can achieve the carbene ion formation. Whatever carbene ion generated will participate in a condensation with another mole of ester. That's the reason why there is a new bond formation. You can clearly notice the new carbon-carbon bond originated between the two segments of the ester. Whenever new carbon bond formation is possible, you are supposed to go for the charge back polarization, and here is the double bond formation, and you can discard the ethoxy functionality so that you can achieve alpha beta keto ester formation. Beta keto ester formation is possible. This is the way a final product could be achieved by Claisen condensation process. What conditions we require? Base must be present. Moreover, strong base is required, like sodium ethoxide, or else you can also add sodium hydride. Solvent suitable for this reaction, either ethanol, sodium ethoxide are suitable for this one. Substrate scope will be Claisen condensation involves the two ester molecules, right? Mixed Claisen condensation can also proceed at giving rise to ester and ketone as a mixture of products. Additionally, there is a provision for another named reaction Beekman within the single reaction, within the same reaction criteria. There is a provision beta keto ester formation as a ring structure. So there is a provision, there is a competing factors operated within the molecule in this Claisen condensation process. In the historical perspective, Ludwig Claisen is the scientist who successfully accomplished this named reaction in the year 1881 and introduced this new chemical reaction. Contributing significantly in the field of organic synthesis, his work laid a foundation for numerous synthetic methodologies. Claisen condensation remains a cornerstone reaction in the organic chemistry. Claisen condensation is very potential for the organic chemistry, chemical reactivity. So many examples are provided. If you go with the ethyl acetate, there is a formation of ethyl acetoacetate in addition to the ethanol byproduct. If you are choosing ester as a phenyl acetate and another ester as methyl acetate, both are asymmetrical in nature. Both are not similar exactly as earlier one. Since the reactants are different, here the product will be again a kind of aromatic ester compound. You can clearly observe. Again, it is a part of beta keto ester. Methanol is the byproduct. You can notice. So being the reaction is successfully established within the laboratory, now we have to understand what applications we have. Without application perspective, entire research will go waste. That's the reason why let me explore the reactive applications of Claisen condensation. If you want to synthesize the extended chains with a beta diketone, so that this Claisen condensation is more suitable for this kind of synthesis. In order to achieve aromatic diketone, we need to go for the ethyl benzoate as one of the reactant, and acetophenone as another reactant, so that here beta diketone formation is possible. Sorry. If the same reactant is having two ester functionalities in their terminal carbon atoms, this is also possible to go for the intermolecular Claisen condensation, giving rise to annular systems, where I am adopting diethyl adipate as a starting material, where the single molecule is with the suitable substitutions, suitable ester functionalities are on the same compound. I am applying the strong base like sodium ethoxide under aquated acidic conditions. There is a provision for the generation of a five-member ring system with the beta keto ester functionality with the ring system. So this is the exceptional intramolecular cyclization taking place within the same reactant. Beta keto ester is the provision for this one. New carbon-carbon bond formation obviously taking place. Chain elongation is the common thing you can clearly observe by this Claisen condensation process. Industrially, so many kind of industrial materials introduced like flavoring agents, fragrant agents, benzyl acetone, cinnamates. All this can simply synthesized by this Claisen condensation process, right? Let me conclude this named reaction. Claisen condensation is very powerful, very versatile reaction in the origin of carbon-carbon new bond in the perspective of organic synthesis. Ability to generate beta keto esters, diketones, relatively mild conditions are the added advantages that will give indispensable tool for the chemist in order to introduce the new kind of compounds. Mastery of these reactions and variations in the essentials of any student, teacher, or researcher in the field of organic chemistry, this is the interesting field. So as we already aware, it is the flavoring agent. You can add a fragrance over there and so many kind of taste improvising agent. It will be so many components, drinks, soft drinks, or edible items can be embedded with this kind of beta keto ester. Ester is fruity in nature, right? That's the reason why fragrant industry is most reliable on this Claisen condensation reaction. Claisen condensation, ester formation taking place, ethyl acetate as a starting material, ethyl acetoacetic synthesis is accomplished by this process. Crossed Claisen, if you are going to perform two different esters to be taken, not the single one, rather two different mixture of esters are the starting material so that benzyl acetate, ethyl acetate are taking part and giving rise to the product. Diekmann condensation is a competing reaction over there. Intermolecular Claisen condensation and diester formation is diester is the starting material taken. Cyclic beta keto ester formation is taking place 5-membered or a 6-membered ring formation with the diester form. This kind of types of Claisen condensations you can clearly observe. By this, we are going to conclude the session. Hopefully, this is really informative and applicable for your examination perspective and also the kind of competitive exams. Thank you very much. If you observe the channel called World of Competitive Chemistry continuously, you will get the much worthwhile information for your future endeavors in the chemistry for the preparation, orals, research as well. Thank you, Varendot, for your patient listening.